after that. So one thing that we did last time was we did lattice energy, which was what that gaseous ions, they would join to form a solid ionic lattice, and that was what lattice energy was. The energy that is released when ionic bonds are formed, when you have lots of gaseous ions forming an ionic lattice, right? So Born-Haber cycle was used to indirectly calculate this value, like what amount of energy is released when bond formation, ionic bond formation happens, when a crystal is formed. So the rule was that what the Born-Haber cycle was basically consisted of, it was basically this cycle. This was a simplified version, where what would happen is that you would start with enthalpy change of formation, that elements get together to form an ionic lattice. So that's enthalpy change of formation, when something gets formed from its elements. And these are the steps that are involved. Okay, this bigger loop, that's the steps that are involved. What do you need to do? You need to break the bonds in the elements first. Magnesium metal needs to be atomized, which means that you have to turn it into atoms. Chlorine molecules, where Cl, Cl are bonded together, their bond needs to be broken so that you get Cl gaseous atoms. So the first step was atomization. Then you would ionize them. So Mg has to be turned into Mg2+. It should lose electrons. That's the first and the second ionization energies. And chlorine has to gain electron. That's known as electron affinity of chlorine, which is kind of the opposite of ionization energy. And once ions are formed, they would get together to form the ionic lattice, which is lattice energy. So this was the path that you would follow. So enthalpy of formation would be equal to all of this. But the cycle would often be drawn in this way. The same cycle would often be drawn in this way, where you would have, where you would have, just one second. So you would, so you're going to have your enthalpy change of formation. The only difference is that the Born-Haber cycle is usually drawn according to the energy axis. Endothermic goes up, exothermic goes down. So enthalpy of formation. So these are your elements. You atomize, you break bonds, and then you break the bonds of Cl. You get Cl gaseous atoms. Then you ionize them. You make Mg lose electrons, and you make Cl gain electrons. So you end up with ions, and the ions get together to form. So this part is exothermic. They form MgCl2. So this is exactly the same cycle. So we're just going to do questions on this. TK, every time it's going to be the same exact Born-Haber cycle. TK, so let me open the questions. Ye clear hai na ki Born-Haber cycle? Ahmed, is this clear? Hasina, is this clear? Tasneem, is this clear?
Yes.
So one second, TK, where's the, there's a sheet which had lattice energy written on it. Just a second. Let me just check this one. Sorry, these are notes. One second. He gets this one. So this one. So we're gonna just do questions. I don't know if we did have any questions. Let's start with this one, TK. The first one. I'll share the worksheet and I'll share the solved version for this one as well. TK. So we'll just do questions related to lattice energy. TK. Remember, you get a very typical 5-6 mark questions in total on lattice energy every time. Now this one is about it's about enthalpy of formation of K2O. Now potassium oxide. Now that's your ionic lattice over here. So we need to. So what we need to do is he's asking us to calculate the lattice energy of this thing, and some data is provided. So we're going to use that. Now I can draw the simplified version, which is you start off with enthalpy of formation. Enthalpy of formation is what? The element potassium solid. The other element is oxygen, which is gas. And together they're going to form what? Together they're going to form K2O. Ionic solid. So this one is delta HF, enthalpy of formation. Enthalpy of formation, the product has to be 1 mole. So the elements have to be balanced accordingly. So this would be, as the first one is going to be 2 potassiums, and this is going to be half O2 gas, right? So that's my enthalpy of formation, and I have the value for enthalpy change of formation, which is given over here. That's minus 361. So this value is already given to me. So karna kya isme, I just need to atomize, ionize, and then form the lattice, right? So the first step is I've got atoms. So I've got the element, and I'm going to atomize them in one go. So I'm going to do both atomizations, and so potassium turns into gas atoms, and oxygen also turns into gaseous atoms. So how would that happen? For that potassium solid to potassium gas, that is atomization, which is given over here. That's given as plus 89. So this is going to be plus 89 times 2 because there are 2 potassiums. Now for oxygen, the atomization is not quoted over here. So what do we do with oxygen? For oxygen, all you have to do is you have to break the oxygen-oxygen bond, and you'll get the oxygen gaseous atom. That's it. So you just have to break the oxygen-oxygen bond. So for that, you need the data booklet for you with your. So we'll open the data booklet. Isko khulne do zara. So in the data booklet, the oxygen-oxygen bond is given as 496. That's provided. So I'm going to use that. So breaking the oxygen-oxygen bond, that's 496, but divided by 2 because I'm not breaking 1 mole of oxygen bonds. I'm actually breaking half moles of oxygen bonds. So I'm going to divide that by 2. ठीक है, ये clear है? Is this part clear?
Yes, sir.
ठीक है, 7 clear है?
Yes.
So that's the first step. ठीक है, remember just 3 steps. Atomize, after that you're going to ionize. So we're going to ionize. I'm just going to do that in one step again. Potassium needs to be turned into ions, potassium +1, and the oxygen has to be turned into an ion as well. That's -2. Now it's the ionization energy, the first ionization energy of potassium. Where do I get that? That's again in the data booklet as well somewhere. So these are the values for the first, second, third, and fourth. Given. So I need to just find potassium. Where's potassium? It's over here. Potassium is 418. That's given. So potassium is 418, but times 2. You have to be very careful about moles. So potassium ka ye, potassium turned into potassium ions, and there are 2 potassium. So I just multiplied it by 2. Oxygen needs to be turned into oxygen -2. For that, you need electron affinity. That's given over here. Electron affinity of oxygen is -141. And then oxygen has to gain the second electron. That's the electron affinity of oxygen -1. That's +798. Okay, so this just means that the first electron was gained by oxygen, then it became -1, then the electron was gained by oxygen -1, then it became oxygen -2 eventually. So these values are given. Now this step over here, the last step, that's your lattice energy. Okay, gaseous ions end up forming 1 mole of ionic solid, and that's your lattice energy. So you just have to find lattice energy. So the rule is that one path is equal to the other path. What I'm just going to do is I'm just going to make lattice energy because I need to find lattice energy. So lattice energy would be equal to this entire path. ठीक है. So lattice energy is equal to, you go all the way back and come back. So lattice energy is, if this is my starting point, I need to go over here in the backward direction. So all these signs, they must invert. So it's going to be minus 418. अच्छा, ये कोई कैलकुलेटर पे करे ये, ठीक है, plus 141, ठीक है, all these signs are reverting, minus 798. Then I need to go in the backward direction again at this point, so it's going to be minus 89 times 2 and minus 496 divided by 2, and then I have to go. Okay, this is fine, so that's minus 361. Okay, what is the answer for lattice energy in this case? You know, calculate here, calculator. Asina, do you have a calculator? Okay, minus 418. How do I? So plus 414 minus 798 minus that's minus 89 times 2
minus 2280.
2280. Okay. So the answer is minus 2280 kilojoules per mole. Okay. Remember, it's around always minus 1000 to 4-5,000. Okay, minus 2280. Okay, two people got this. So that's it. Atomize. This is the part where you ionize. ठीक है, बस moles का ख्याल रखना है. ठीक है, make sure कि which thing gets multiplied by 2, which one does not, and then you have the lattice energy. So the next one is easy, that state whether the lattice energy of sodium oxide will be more exothermic, less exothermic, or compared to K2O. So Na2O versus K2O. Who has the stronger lattice? कौन होगा इनमें से? Which one has the stronger lattice? I mean, they have exactly the same charges. This is plus 1, this is minus 2, this is plus 1, this is. Except K, sodium is the smaller ion. Sodium is just 11 electrons, so it's 281. Bulky, it's just 28, not even the 1 at the end, because it's lost that 1 electron. So sodium has a lot smaller. Just 1 second, it's hanging up. So the consort, the smaller one is the one that's the stronger one. Just hold on 1 second. Okay. So this one is the smaller ion, which is why it's going to be the stronger lattice. It's going to be more exothermic. It's going to release a lot more energy when this is formed.
Sir?
Yes.
But didn't it mean if it's a smaller ion, that means that it would have higher repulsion between the electrons?
No, that was if it's a smaller.
If it's a smaller ion, there would be more repulsion between the electrons.
No, that you're mixing it with an exception. The first thing is, when you're a smaller ion, you're closer together, right? So between the ions, there's going to be more attraction, right? The bigger ions are further apart. What you're confusing it with is I did electron affinity somewhere over here. It was this one. Now in electron affinities, we did that atoms try to gain electrons, right? Fluorine, chlorine, bromine, and iodine. In that case, when you had a very small atom, the electrons were so tightly packed that they would repel the other electron that's coming in, and it would become harder to actually gain electrons. Okay, so that only applied, it was just an exception. Asina, is that clear? So that was only true for this one exception. Otherwise, the repulsion from the electron is not really that big an issue. It only applies to fluorine because it's got too many lone pairs. Otherwise, that's usually not an issue. So next one. Now the Born-Haber cycle is already drawn, right? Can somebody tell me what? You just have to label this. This is about sodium oxide. It's the same Born-Haber cycle. What is 4? What do you call 4?
Enthalpy of formation.
Formation.
Formation elements are forming this thing. So this one over here is delta HF. So this is delta HF. Now they're saying that they're atomizing sodium, right? So what is A then? If you atomize sodium, what would A be? Well, what are you going to write here?
2Na gas.
Na gas.
Bas Na gas, okay. So it got atomized, right? Then you have, what happened? What happened over here? Oxygen, nothing happened to oxygen. This thing happened to sodium, right? So what is that? Like what would you call this? Amit, क्या होगा?
Ionization energy.
ठीक है, बस ionization energy, that's it. The first ionization energy of Na. Achha, the first ionization energy of Na. Then oxygen got atomized, so it's obviously what? Oxygen gas. That's it. That's B. So, and then oxygen is getting ionized. Oxygen is gaining electrons. Sodium, nothing is happening to sodium. Oxygen is gaining electrons. So that's so jab element electron gain karta hai, that's known as electron affinity. And you can either call it the first and second electron affinity, or it's the electron affinity of oxygen. So firstly, oxygen gains electrons, then it becomes -1. Then oxygen -1 gains the second electron. So it's the electron affinity of O-1 as well. Okay, number 3. What is number 3?
Lattice energy.
Okay, that's lattice energy. Okay, it's atomized, ionized, and then the lattice got formed and you got sodium oxide. That's it. Okay, so you just had to identify all of them. That was it. As he's asking you to actually calculate lattice energy, which we, as a sodium, we did. किसके लिए किया था पहले? अच्छा, potassium के लिए. So that's going to be exactly the same. That's given. Everything is given, so you can just do that. Okay, let's try another one. अच्छा, इसका बता दो, magnesium oxide or sodium oxide? Who's the stronger lattice? The charge, kiska charge zyada? Charge is greater for Mg. N is +1. So not only does Mg have a higher charge, but at the same time, it also has the smaller ion as well. ठीक है, हमने किया भी था कि Mg and Na are basically isoelectronic, which means that they have exactly, but this was 282, but now it's 28. This is 281, but now it's lost electron, so it's 28. So they have exactly the same electronic configuration, but because magnesium has more protons compared to sodium, magnesium is the one that's going to be smaller in size because of the greater attraction. Or magnesium oxide, I did discuss uses as well, that it was used in furnaces. It's a very strong material, ceramic hota, it's known as ceramics, furnace lining, heat shields, etc. So next one. Ortho question, that's it. So the next one is, again, we just have to draw a bond. I said, remember, this question is going to come in almost every exam. That's it. I said, this one, complete a fully labeled bond, calcium chloride. So I'm just going to skip steps, TK. You can just, I said, now he's exactly saying a fully labeled Born-Haber cycle. So you can't skip steps, TK. You just have to do every single thing. You can label it properly. So now I would have to actually go into write every minor step. Agar ye na likha hota na, I would just have done atomization, ionization, and just ended it, right? So I would have to first, what do I do? Atomize calcium. Leave Cl2 as it is. Next step. Calcium is already ionized, so I'm going to, already atomized. So I'm going to atomize chlorine. So my atomization of both substances is complete. So this is enthalpy change of what? Atomization of calcium.
Yeah.
Or that's enthalpy of atomization of Cl times 2, because in atomization you just form one atom. Yahan pe I'm making 2 atoms, so times 2. So after this, I'm going to ionize them. Again, I have to label every step. So I'm going to ionize calcium first. So calcium turns into iron, loses 2 electrons. Cl as it is. So that's what, first plus second. Ionization energy of Cl. And after that, Cl has to gain electron. Now, yahan pe kahin given hoga Cl gaining electron. That's exothermic, right? The first electron affinity is always exothermic. So the arrow has to come down now. So from this point, I need to make Cl gain electrons. So the arrow has to move downwards. It's got to lose energy. So calcium is already +2. The 2 Cls have now gained the 2 electrons. So it's becoming 2 Cl minus 1. So this is electron affinity of Cl times 2. And then finally, you've got your lattice energy. That's it. Isme bas moles ka, make sure you get the moles right. Cl, electron affinity of Cl has to be multiplied by 2. That's fine. Everything is fine. You just have to fill in the data now. And you have to find what? The lattice energy, that's it. So you have to find the lattice energy. So for that, this has to be equal to the other path. So lattice energy is the arrow has to go in the opposite direction. So lattice energy is basically equal to plus 349 times 2. The arrow piece ja raha hai, I have to reverse the arrow. The first and second ionization energy of calcium has to come from the data booklet, which is 590 and 1150. That's coming from the data booklet. So it's going to be minus 590. So this value has to have a negative sign as well. Enthalpy of atomization of Cl, that's given over here. Is it? The enthalpy of atomization of Cl is not given. So what is enthalpy of atomization of Cl? It's just breaking the Cl-Cl bond. You just have to break the Cl-Cl bond. So Cl-Cl की जो bond energy है, that's given over here. 242. Okay, so it's going to become minus 242 because you're going in the opposite direction. And I'm not going to multiply it by 2 because if you break the Cl-Cl bond, you get 2 Cl atoms. So you just have to break one bond because you don't have to multiply it by 2. You can automatically with bond energy, you actually get 2 Cl atoms. So you don't have to do anything. Up here, enthalpy of atomization of calcium also has to have the opposite sign. So that's minus 178. And then enthalpy of formation, you don't need to change the sign of that. That's minus 796. So please try and calculate what do you get for this. Or ye clear hai why I did not multiply it by 2 when I used bond energies.
Yes, sir. Clear.
Just remember that you may face a stress. People get confused. Yes.
Sorry, sir. I had a question, sir. I thought for atomization, it's gonna be half of bond energy.
Yes, it will be half a bond energy. What is let me clarify this. Cl2 forming Cl gaseous atoms, right? Now in enthalpy of atomization, you form 1 mole of gaseous atoms, right? So this is enthalpy of atomization of Cl. Asina, is that clear?
Yes, sir.
So you're breaking how many bonds? You're breaking a Cl-Cl bond, but you're breaking half moles of it, right? So it's going to be half the bond energy of Cl-Cl, right? Is that clear?
Yes, sir.
But over here, how many Cls do you want to form? You don't have to form 1 Cl atom, you want to form 2 Cl atoms. So that's why you're going to multiply it with 2. Is that clear?
Yes, sir.
So that will become a complete bond energy. Basically, we're not doing that. We're basically doing this. We're forming, instead of forming 1 Cl gaseous atom, we're actually forming 2 Cl gaseous atoms. So that's breaking 1 mole of bonds. Okay, which is why you're not going to multiply it by half. Is that clear?
Yes, sir.
So which is why you just need 1 bond energy. So I just wrote minus 242 over here. I said, did anyone get the answer for this?
Sir, it's negative 2258.
Yeah, this one is negative 22. Yeah, always remember it's going to be negative and somewhere between minus 1000 to 3000. It could be larger, it could be smaller as well. So TK, is this clear, this one?
Yes, sir.
Yes, sir.
So let's try and let's try and do this one. TK, again, it's similar. The only thing is, just to confuse you, Mg is normally 2 plus. Like over here, they're trying to actually form MgCl. So over here, Mg is actually not 2 plus. So you just have to go along with it. Over here, they're saying that Mg is actually +1. And Cl is -1. Otherwise, it's normally MgCl2. So you just have to go along. It's not over here, the lattice that is forming, Mg is actually +1. So if they're not asking me, they're just saying that it's helpful to construct an energy cycle. I'll just construct the simplified one. which is if I've got enthalpy of formation. I mean, I'll actually do it that way. That let's start with enthalpy of formation. Now, enthalpy of formation is we want to form MgCl solid. It's going to be formed from what? Mg solid element and half Cl2 gas. So that's my enthalpy of formation. I'm going to atomize everything in one go. So I'm going to get Mg gaseous atom, that's endothermic, and I'm going to get Cl gaseous atom, that's also endothermic. I'm going to ionize them in one go, that's, and I'm not going to form Mg2 plus, I'm going to form +1. I have to just follow what they're doing. And then the gaseous ions would finally that's your lattice energy. So I just have to, this is the simplified version, not labeling it properly. So enthalpy of formation is given, that's -106. Atomization of Mg is given, that's +147. The atomization of Cl, now over here, I'm actually forming one Cl gaseous atom. So that's basically equivalent to bond energy divided by 2, because I'm just breaking half moles of Cl2 bond, right? So that was -242. So this part will be -242. Yeah, I'm just breaking half moles of Cl bonds to get a Cl gaseous atom. That's why the bond energy, I'm not breaking one bond, I'm just breaking half a bond or half moles of bonds. Then I'm going to ionize them. Where's the ionization energy of Mg? That's we're going to take it from the data booklet. So Mg's first ionization energy is 736. That's 736. The electron affinity of Cl is given, that's -349. So we've got one path being equal to the other path. So lattice energy is basically equal to the entire other thing. The arrow has to go in the opposite direction, so that's 736 minus plus 349 minus plus the minus 147 minus 242 divided by 2 and then minus 106. So kya aa raha hai iska answer? What do we get?
Sir, -761.
-7?
61.
And this looks like a weak lattice, like it's +1 -1. So probably, so that's why it's kind of less. So that's fine. It's -761. Okay. Just be careful with this enthalpy of atomization thing for whether you have to break 1 mole of bonds or whether you have to break half moles of bonds. Okay. Over here, I just have to break half moles of Cl bonds to atomize Cl. अच्छा इन दोनों में कौन सा ज्यादा होगा MgCl2 or MgCl? Which one has the more exothermic lattice energy and why? Humayed, who's the stronger lattice?
So the stronger lattice will be MgCl2 because Mg has +2.
I think it's got the greater charge. Who's got the smaller radius, by the way?
Is it also MgCl2, sir?
So the radius of, because the radius of Mg +1 is basically I mean, it would have been 282, but now it's going to be 281. So it's still 3 shells, right? Mg plus 2 is 12 electrons, so that's 282, but it's lost 2 electrons, so it's now 28. So it's so this one is actually smaller as well. Mg plus 2 is. So it's got the smaller ionic radius as well. ठीक है ये बात clear है? So next one is NaCl and MgCl, right? It's again, I mean, the charges are exactly the same. So who's the stronger lattice? Na is 11 protons, this one has 12 protons. Now, they've got the same charge, but who's the stronger lattice?
Is it Mg's high number of protons?
Are you sure? But for that, it has to be isoelectronic. It's actually not isoelectronic.
Oh, okay.
ठीक है, Ahmed, it's I mean, this one is the electronic configuration is 28. 12 electrons, one is lost, so it's 281, right? So basically, this one has 3 shells, so it's obviously going to be the bigger one. So this is the one that's got the smaller ion. ठीक है, तो वो जो proton वाली बात है ना, you can only do that thing if they have the same electronic structure. If not, like in this case, this one is clearly the bigger one. ठीक है, is this clear?
Yes.
So that's again sodium oxide. So the other ones are going to be. I'll send this as an assignment. There are a couple of questions. Do all of the questions. Even the ones that we have already done. So that's Born-Haber cycle. We'll just do some more questions right at the end. I mean, we'll just continue on with energetics. Okay. The assignment or plus the solved version as well. Plus I'll send the video lectures for the solved one as well. As moving to the next part of energetics that's also related to lattice energy. It's actually related to group 2. It's related to group 2 solubilities. I mean, that's the only thing you have to study in group 2 in A levels. So I mean, the question is usually about solubility of hydroxides. अच्छा ये वाला. अच्छा, this thing is somewhat overlapping with group 2, but that's the only thing. We're not going to study group 2 separately. We're going to study it over here. Now, for this, we need to understand a couple of definitions first for enthalpy changes, which we will be using. As a definition, first one. Number one is enthalpy change of solution. As an enthalpy change of solution. Basically, the idea is simple that if there's any one mole of any substance, so it's the energy that is released or absorbed. It could be exo, it could be endo. When what happens when you dissolve something? As a 1 mole of substance is completely dissolved, in water to form an infinitely dilute solution, which just means that you're forming a very dilute solution. And that's it, TK, that's it. So if I have NaCl solid, 1 mole, I'm going to try and dissolve it. And if that 1 mole dissolved, some amount of energy is released or absorbed. So it would dissociate. Ionic compounds, they always dissociate when you dissolve them. Their ions, positive and negative ions, they scatter in water and they completely dissolve. So that's enthalpy change of solution, TK, NaCl dissolving. So the energy change, whether it's endothermic or exothermic, that's the enthalpy of solution of NaCl. If I have a covalent compound like ethanol, which is a liquid, I mix it in water. Now it's not going to dissociate because covalent compounds, they don't dissociate, they don't ionize, they just mix with water. They form hydrogen bonds if they are very soluble. So it's going to form C2H5OH aqueous, that's it. So this thing is enthalpy of solution of enthalpy of solution of ethanol, that's it. So that's it. You dissolve 1 mole of substance, any substance, and it dissolves, it releases energy or it consumes energy. And remember, if enthalpy of solution is exothermic, that just means that substance is very soluble. Like you don't need to do anything. Substance is soluble. It mixes with water. It forms bonds with water. It is attracted to water. Bond formation is exothermic. So that means you're not breaking a lot of bonds. You're actually forming bonds with water. So that means it readily dissolves. So substance is soluble. And it's going to become more soluble. Exothermic things become more soluble at lower temperatures. बस ये last बात है कि vice versa, if enthalpy of solution if enthalpy of solution is endothermic, then that basically means that it requires energy to dissolve. You would have to heat it. So substance is not very soluble. And it will dissolve at higher temperatures. It requires energy. Okay, so is this clear that what is enthalpy of solution? Okay, clear?
Yes.
Okay, so we'll continue with this tomorrow then. Okay, we'll probably just end the whole enthalpy of solution, and lattice energy part we'll probably finish this and we'll do some past papers with this. Okay, so we'll complete this tomorrow. Okay, I'll film video recordings and I'll send you the notes, notes and the assignment for Born-Haber cycle. Try and complete that. Okay.
Okay, sir.
Okay, everyone.
Thank you, sir.
Okay.
Take care. Allah Hafiz.
Thank you, sir.